Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody. Welcome to Wednesday night math night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And I just love what we get to do, which is help you become more competent and confident in your math skills. Competent and confident in your math skills. If you have no confidence, but you have all the confidence in the world, you know how to solve all the problems, then that confidence is going to affect you when you take that exam. But if you have all the confidence in the world, but you just need help with those skills, then that competence needs to be built up. And so we are here to help you with both of those. So all of that said, we just love being here every single Wednesday. If you have any questions at all, I always have a next week section, and I'm going to start that right now. So we always have a next week section here. And so if you have questions that you're like, man, I wish you would go over this type of skill, please let me know in the comment box. I am happy to help you. I am happy to include that in the upcoming weeks. So leave me a comment in the comment box and be like, hey, can you go over probability, or can you go over areas specifically of circles or whatever? I'm happy to include that in the upcoming weeks. All that said, let's go ahead and do a little get to know you activity. It just makes it feel less like a computer screen and more like we're hanging out at a coffee shop and doing math. So where are you from? What test are you prepping for? And the get to know you question. Do you have any summer plans? I feel like we're at the very end of April. We're getting super close to summer. And so do you have any summer plans? We don't really have any summer plans. We have a wedding in September that we're going to go to, but we don't really have any summer plans. So where are you from? What test are you prepping for? And do you have any summer plans? Let me know in the comment box, and we will get to know each other a little bit more. We will be here for about an hour solving problems together. I apologize if I'm coughing. I am not feeling the best. I feel like this has been going on for so long. Maybe I have allergies. Maybe I need allergy medicine. I don't know. But last week my voice was shot. The week before I feel like my voice was shot. This week my voice is shot. I don't know what's going on. So I'm going to be drinking a lot of water and sucking on a cough drop. So to help hopefully avoid this voice from completely losing it. All right, so let's go ahead and get started with the first problem. I am going to go through problems pre-K through 12. And as I go through some of these problems, I always try to relate every problem back to all grade levels. So while you may not need to know how to solve this problem particularly, I'll find something in that problem that relates to you. So even if you're like, oh, there is no way I need to know how to do that problem, there's something in that problem you'll need to know how to do. And so I will make sure I call that out just so that you can get the most out of the time together. So let's go ahead and get started with our first problem. What is the unit digit of 34 to the 26th power minus 21? What is the unit digit of 34 to the 26th power minus 21? All right, so this is an interesting problem because it's a problem that we can't really solve with a calculator, right? 34 to the 26th power is an extremely high exponent. And if I was to sit and do 34 times 34 times 34 in my 4-function calculator, that would be almost impossible, purely because number one, there's a lot of room for calculator error, like typing it in. And number two, there's a lot of 4-function calculators don't go out that many digits. And so it creates this problem because we can't see the unit digit because it's usually like 2.9 blah, 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 e to the like whatever power. Like the calculator has a hard time with numbers that become this big. However, what's interesting, and if you didn't know this, this is kind of a fun fact, is exponents have patterns. So let's take a look at this. 34 to the first power. We're going to do it out, I don't know, 5. Let's do it 5 times. So 34 to the 4th power and 34 to the 5th power. So this is that moment where I'm telling you like, hey, you may not need to know how to do this problem, but you do need to know what an exponent means. An exponent tells me how many times I'm doing that item. So this is 34 to the first power, which is just 34. This is 34 to the second power, which means I'm doing 34 times 34, 2 34s. So 34 times 34 is 1,156. 34 times 34 times 34 is 39,304. 34 times 34 times 34 times 34 is 1,336,336. And 34 times 34 times 34 times 34 times 34, 5 34s is 45,435,424. What do you notice about the unit digit in all of these responses? What do you notice about the unit digit only? There's a pattern there, isn't there? 4, 6, 4, 6, 4, and that pattern is going to continue. So now if I subtract 21 from all of these, minus 21, minus 21, minus 21, minus 21, minus 21, and I do 34 minus 21, I get 13. If I do 1,156 minus 21, I get 1,135. And at this point, I don't need to type in this entire number minus 21 because it's only going to affect the ones and the tens digit. And I'm only looking for the unit digit, which is known as the ones digit. And so I can just do 304 minus 21. I don't need to do 39,304. Like I can save myself a little bit of time. And this equals 283. And then 336 minus 21 is 315. And 424 minus 21 is 403. And now if we go back and look at this pattern, 35353. So what kind of pattern can I use to figure out what the 26th digit is going, or the unit digit of the power of 26 is going to be? Well, I could sit here and do this 26 times. So I could go, for those of you who struggle to find these patterns, that's okay. You could go 3 5 3 5 3 5 3 5 3 5 3 5 3 5 3 5 3 5 3 5 3 5 3 5 3 5, and the 26th digit would be 5. But you could also look and see that for all of my even powers, it's a 5. And for all of my odd powers, it's a 3. And so because this is an even power, I know it's going to be a 5. Was this hard? No. Was there room for error? Yes. I could have done one too many tallies, or my hand could have been moving faster than my mouth when I was doing that. And so that's where you want to mitigate the amount of potential for error when you're doing tests like this. However, it works, right? But the evens have 5s as their unit digit, and the odds have 3 as their unit digit after we subtract that 21. And so D is the correct answer. Let's move on to the next problem. If the ratio of the area of similar triangles, triangle ABC and triangle DEF, is 3:2, what is the area of triangle DEF? What is the area of triangle DEF? Round to the nearest 10th if necessary. All right, so in this problem, we see that we have similar triangles. In this problem, we see we have similar triangles, which means that the proportions of these triangles is the same, the proportions. It doesn't mean the triangles have the same measurements, but the proportions are. And it says if the ratio of the area of triangle ABC and triangle DEF is 3:2, what is the area of triangle DEF? So what I can do here is I can look to see, okay, what is the area of ABC? Let's start there. What is the area of ABC? Well, I know the area of a triangle equals 1/2 base times height. Everybody needs to know the formula for area of a triangle. And even if you don't need to know it because you have a reference sheet, what you do need to be able to do is apply it. So when I look at this triangle, my base is 7, and I'm going to use a different color so we can highlight it. My base is 7, and my height is 4. Why is my height not 6? Because when I measure the height of something, I'm going to go perpendicular to the ground. So if I'm measuring the height of this water bottle, I'm going to measure it based on its distance straight up and down. I'm not going to put my measurement tool way out here and measure it at an angle, right? Or at a slant. I want to know how tall it is from the ground to the top of the water bottle. So that said, the height is 4. We don't do slant height. So I can figure out that the area equals 1/2 base times height. 7 times 4 is 28. So 1/2 of 28 equals 14. And we know that the ratio of the area of ABC and DEF is 3:2, which means ABC is the bigger triangle and DEF is the smaller triangle. Yes, the image shows that ABC looks bigger than DEF, but I want you to remember here that we do not do anything based off of looks. We do not do anything based off of looks when we're dealing with mathematics and especially geometry, because a lot of times things are not drawn to scale. Now, because of the language that they used here, we know that ABC is bigger and DEF is smaller. Because ABC has the 3 and DEF has the 2. It's a 3:2 ratio of the areas. And I'm going to reconnect my iPad right here. It's a 3:2 ratio of the areas. And so because of that, when I look at my answer choices, when I look at these answer choices that they've presented me, there's only one possible correct answer. There's only one possible correct answer. And that is 9.3. Why? Because it's the only area that is smaller than the area of my triangle ABC. It's the only area that is smaller. They're not going to be the same. It's not a ratio that's exactly the same, and it's not going to be bigger either. Now, you're like, well, what if that's not the case? Like, what if my answer choices don't lend me to that? Well, then in that case, we can set up a proportion. So we can say 3:2 equals 14 to X. How did I come up with that? Well, 3 is triangle ABC, 2 is triangle DEF. So then I'm going to compare it to the actual areas, ABC, DEF. As long as you have the same thing on the top as you do on the bottom, like whatever you're comparing, then you're good to go. Now I can cross multiply. I can only cross multiply because there's an equal sign in the middle. And I'm going to continue that up here. So 3 times X equals 14 times 2 is 28. Divide both sides by 3. And X equals 9.3 repeating. And it said round to the nearest tenth. So my answer is 9.3. Questions about that? All right, let's move on to problem number 3. Omari went out to dinner with 4 friends. The bill before tax and tip cost $156.87. The tax applied to the bill was 7%, and they decided to leave a 22% tip after tax. If they decide to split the bill evenly, how much did each person spend? If they decide to split the bill evenly, how much did each person spend? All right, so Omar and his 4 friends went out to dinner. So how many people are eating dinner? That's the first question. There are 5 people eating dinner. One of the most common errors that people would make on this problem is they will divide by 4 because they see 4 friends. But Omari went to dinner with them. And so there are 5 friends that are splitting this bill. So I need to figure out what is the tax on the bill, what is the tip on the bill after the tax because it says 22% tip after tax. And then add it all together and then divide, right? So step 1 tip, step 2, step 1 tax, step 2 tip, step 3 add it all together, step 4 divide by 5. And I will often create some sort of similar plan when I know that I have a multi-step problem. This problem is appropriate for everybody because percentages, converting percentages into decimals, doing that multiplication really is like a 5th grade skill. So unless you're doing pre-K through 3, this is really a problem for everybody. Now, pre-K through 3 people, you do need to understand how to do some multiplication and multi-step word problems and all of that. So knowing the process, even though this may not be the problem you have to solve, is important. So how do I find what 7% of 156.87 is? Multiply. Now, how do I go from a percent to a decimal? Because I can't do $156.87 times 7%, or I can't do it times 7 because that's not equal to 7%, right? And I know that because when I do 156.87 times 7, I end up with $1,098. And that just doesn't, like, when we think about real world applications, that doesn't make sense in the context of the problem. My tax is not going to be $1,098, right? And so when we think about the context of the problem, that doesn't make sense. So I need to go from a percent to a decimal, move the decimal place to the left. Now, if there is no decimal, then we can put in an imaginary decimal at the end of that number all the way to the right. So to convert this 7% into a decimal, I can go 1, 2, and plot my decimal right there. So this now becomes 1, 2, an imaginary 0 goes there, so 0.07. So now I can use my 4-function calculator. And if I didn't have a 4-function calculator, then I could do it by hand. But I have a 4-function calculator today, so I'm going to use it. $10.98. Now, it shows 10.9809, and I'm just rounding it off to 0.98. This 0 just tells me that I'm going to keep that 8 as an 8 because we're dealing with money. So I'm not going to keep 4 decimal places out. So this is the tax. Now, I'm not going to find the tip based off of this value. I need to add the tax and the bill to figure out the tip because remember, this key thing that they told us was that the tip was after tax, which means that they tipped on the total value of the bill and tax. So let's go ahead and add those two values together. I am going to do this one by hand just so we can see what it looks like. $156.87 plus $10.98. You see that I lined those decimals up. It's important that we line the decimals up so that we're adding single dollars to single dollars, tens to tens, cents to cents. So it's important that we line the decimal up when we're adding. We do not need to line the decimal up when we are multiplying. So 8 plus 7 is 15, carry the 1. 9 plus 1 is 10. 10 plus 8 is 18. 6, 7, 5, 6, 1. So now we have a total bill of $167.85. Now we have a total of $167.85. Now we need to figure out what that tip is. So I'm going to do $167.85 times the decimal version of 22%. And the decimal version of 22% is, move that decimal 2 places to the left, 0.22. So I'm going to use my calculator. $36.927. I'm going to round that off to the nearest cent. But this 7, and this is for everybody, pre-K through 12 needs to know how to round. This 7 rounds up. If it's 4, 3, 2, or 1, it rounds down. If it's 5 or above, it rounds up. So because this 7 is a 7, this 2 is going to round up to a 3. So this actually becomes $36.93. That is the tip. Now I need to add it together. So I'm going to do $167.85 plus $36.93, 5, 6, 7, 8, 9, 17, 7, 8, 14, 6, 7, 8, 9, 10, 2, $204.78. Now, this is where letter D comes in. People forget. They've done so much work on this problem. They've done so much work on this problem that people forget that there's a final step. And so the test makers know that. And so they include that almost final answer as an answer choice because they know that people are going to make that mistake. And so don't be that person. Don't forget to do this final step, which is why I will often create this plan over here so that I don't forget the final step. Because when you're under stress and you're taking that test and you're like, man, I know how to do this problem. Sometimes we make those silly errors because we don't realize we haven't done the final step. Now we have to divide that by 5. So I'm going to do $204.78 divided by 5. Which gives me $40.96. Questions about that problem? No? All right, let's move on to the next problem. Write the equation in point slope form for a line that passes through the point -4, 7 and is perpendicular to 3x minus 2y equals 12. Perpendicular to 3x minus 2y equals 12. All right. So when we're looking at an equation of a line in point slope form, let's just review real quick the difference between standard form, point slope form, and slope intercept form. So we have point slope form. We have slope intercept form. And we have standard form. Standard form is AX plus BY equals C. And really, between you and me, standard form is really kind of useless. It looks really pretty because you have your X and your Y and your constant, but it does not provide us with any information off the bat. So standard form is really not helpful at all. Let's go ahead and look at slope intercept form. Slope intercept form is Y equals MX plus B, where B is your intercept, your y-intercept at that, and M is your slope. Hence, slope intercept form. And your point slope form is going to be y minus y1 equals m times x minus x1, where m is still your slope, just like it was in slope intercept form. And y1, x1 is a specific point on the line. Hence the name point slope form. The mathematicians, when they were creating these names, were not creative when they created the names. And for you and I, that is helpful because it tells us what information is provided within that form. So they want point slope form for a line that passes through the point here. So for point slope form, I need a point and a slope. I already have a point. They gave it to me. Now I need a slope. And the other piece of information that they told me is that it's perpendicular to 3x minus 2y equals 12. Why is that important? Why is that important? Because lines that are parallel have the same slope, and lines that are perpendicular have negative reciprocal slopes. So if it's perpendicular to 3x minus 2y equals 12, once I can figure out my slope, then I can just do the negative reciprocal, and that is the slope for my new line. All of that said, which of these answer choices can I get rid of right away? A and B. A and B are in slope intercept form. And they asked us for point slope form. So A and B are out. And when we look at C and D, I immediately notice that one has a plus and a minus, and one has a minus and a plus. So when I look at my point and my point slope form, if I were to write it out, y minus y is 7, y1 equals m times x minus x is negative 4. X minus negative 4. A negative times a negative is a positive, so this becomes a plus sign. So the correct answer is D, and I didn't even have to put that line into slope-intercept form. What I want you to see is that sometimes you don't need to solve the entire problem. Once you have a piece of the puzzle or two pieces of the puzzle, like in this case, we knew it needed to be in point slope form, and we knew that there was a point, and that was enough information for us to be able to solve it. Now, I know what you're thinking. You're like, well, Amy, what if? Like, what if that's not the case? I will solve it for you right now. However, I just want you to see that it's not always necessary, right? I just want you to see that we don't have to every single time, and that's going to save you some time. But if I wanted to put this equation into slope-intercept form so that I could find the slope, I'm going to subtract 3x from both sides. Why? Because in slope-intercept form, the y is by itself. So I need to get this y by itself. Negative 2y equals negative 3x plus 12. Could you have written 12 minus 3x? Yes. However, in slope-intercept form, the x comes first, and so I want it to mimic that. Could you have written 9x? No, because the 12 doesn't have an x attached to it. And so because of that, this cannot be simplified to 9x. Now I'm going to divide everything by negative 2. And I get y equals positive 3 over 2, because a negative divided by a negative is a positive, x. 12 divided by negative 2 is minus 6. So this is the slope of the line that's perpendicular. So how do I figure out the slope of the line for my line that I need? I'm going to flip it upside down, and I'm going to negate it. So it's negative 2/3. Questions about that? That was a lot of work, but it was good. Linear equations are very popular among a lot of math tests, so understanding this is really critical. All right, let's go on to problem number 5. Sorry, y'all. I had to get a new bottle of water. Describe the transformation that occurred from the equation f of x equals x minus 5 to the third power to the graph of the equation f of x equals 1/2 times x minus 3 cubed plus 2. X minus 1/2 x minus 3 cubed plus 2. All right. So if we're looking at the transformation that occurred from one equation to another, what I don't want you to do or get tempted to do is describe the transformation of this graph from f of x equals x cubed. Because typically those are the transformations that we're looking at. But in this case, that is not what we're looking at. We're looking at the transformation from this graph to this graph. So what I do know is that we are going 2 units up, because remember, transformations on the outside are up and down. Transformations on the inside are right and left. And a number that's being multiplied on the outside gives me a stretch or a shrink. Okay. Now, when I look at my answer choices, shifted 5 units to the right. Well, this graph is shifted 5 units to the right of my original, but it's not shifted 5 units to the right. Like this one is not shifted 5 units to the right of this one. So that's already out. Now, I am going to look at my answer choices and see what's the same and see what's different. So I have shifted 3 units to the left, which is going to be that internal shift. 2 units to the right, 2 units to the left. My external shift, 2 units up, 2 units up, 2 units up. Okay, nothing is different there. So what I really don't need to do is I really don't need to look at that because they're all the same, right? And then a vertical stretch of 1/2, a vertical stretch of 1/2, a vertical stretch of 1/2. Interesting. So what we really are looking at is how much am I shifting from here to here? Well, let's look at a coordinate grid. This right here is shifted 5 units to the right. Remember, inside my transformation, I'm going right and left, and it's going to be opposite of what I would think. So a -5 is a shift to the right, and a +5 would be a shift to the left. Whereas the outside transformation, the green, follows suit with the sign. So I'm shifting 5 units to the right. And that's where my original graph is, or my OG of this problem is living. My new graph is x minus 3. So I'm shifting 3 units to the right from my origin. But now I need to look how much or what is the transformation from this black dot to this pink dot. What is the transformation from the black dot to the pink dot? Because we don't need to look at the up and down or the stretch or shrink because all of that is the same in all of my answer choices. I am shifting 2 units to the left. I am shifting 2 units to the left, which is confusing because it's an x minus 3, which is 2 units to the right of the origin. They didn't ask us to describe the transformation from the origin. They asked us to describe the transformation from f of x equals x minus 5 cubed. And so that's why the answer is D. Does that make sense? All right, let's go ahead and look at problem number 6. How many ways can one select 4 colors from a set of 17 unique colors without replacement if the order does not matter? If the order does not matter. So let's say we have pink and black and red and gray and purple and orange and brown and green and yellow and blue and see-through purple and see-through pink. Okay, so we have all these colors, and they want to know how many ways can we select 4 of them from a set of 17. This is permutation combination. Wow. This is permutation combination all day. But how do I decide which one it is? A permutation is the following formula. N factorial divided by, n minus r factorial. And a combination is n factorial divided by n minus r factorial times r factorial. So how do you know which of the following formulas to use? So let's first talk about which of these is going to give me a bigger answer, more options. Which of these is going to give me a larger answer? Permutation. Why? Because I'm starting with the same amount on the top, but then on the bottom, I'm dividing by n minus r factorial. And here I'm also dividing by n minus r factorial, but I'm dividing by an additional amount times r factorial. So I'm dividing over here by a greater number. So I'm going to have a smaller answer if I'm dividing by a greater number. So permutation is going to give me a larger answer. Okay. Now, how many different ways can I select 4 colors from 17? N is going to be the total number of items that you have to choose from. So in this case, 17 is your N. And R is how many of those items do I want in each selection. And so in this case, that is 4. So which formula am I going to use? I know I'm going to start off with 17 factorial. I know without a shadow of a doubt that I'm starting with that, and we're going to reconnect my iPad. And let's talk about what is even a factorial. What is a factorial? Factorial means that I'm multiplying by all of the numbers down to 1. So 17 factorial is 17 times 16 times 15 times 14 times 13 times 12 times 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So I am doing 17 factorial. I know that because they both start with that. And I know I'm dividing by 17 minus 4 factorial. It's a matter of, am I going to include that r factorial or not? In this case, I am going to include that r factorial because order doesn't matter. In a permutation, order does matter. Order matters. In a combination, order doesn't matter. And you're like, well, if order doesn't matter, why is the number of options smaller? And let me show you why in a minute. Let's solve it, and then I'll show you why. Now, I do not need to plug in 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10 in my calculator. I'm going to show you why. I'm going to show you the long reason why so that you can understand. So I have 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9, and I'm going to run out of space, so I'm going to move it down. I'm going to move it down a little bit, so give me a second. times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 17 minus 4. 17 minus 4 is 13 factorial. So now I have 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Because there is nothing being added or subtracted and it's all being multiplied, factors can cancel out. So 4 divided by 4 is 1. 5 divided by 5 is 1. 6, 7, 8, 9, 10, 11, 12, 13. When you're doing permutations and combinations, what you're going to be left with every single time is whatever the top is up until your subtraction point. So if it's 17 minus 4 is 13 factorial, I'm going to do 17, 16, 15, and 14. I'm not going to include 13 or on because those are all going to cancel out. Now, in a combination, I have in permutation, I would just do 17 times 16 times 15 times 14. In a combination, I have to do 17 times 16 times 15 times 14 divided by that 4 factorial, 4 times 3 times 2 times 1. Now I can do this in my calculator. 17 times 16 times 15 times 14 is 57,120 divided by 4 times 3 times 2 times 1, 24. So 57,120 divided by 24 equals 2,380. All right, now why combination and not permutation? Why does order not matter? Give me less answer choices. Let's take a look at our next slide and I'll show you why. So in this case, it's the same N and the same R, but it's a different kind of problem. How many ways can one create a 4-digit password from a set of 17 unique digits? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, A, B, C, D, E, F, G, like those could be digits too without replacement. In our last problem, we had a bunch of colors and we wanted to choose 4. If I choose these 4, and order doesn't matter, if I pull pink, black, red, gray, pink, black, red, gray, but then I do black, pink, red, gray, does that change the colors that I have? No. Order doesn't matter. I still have the same 4 colors in my bag. I still have the same 4 colors in my bag. I still have the same 4 colors in my bag. So all of these options only count one time because they're the same 4 colors no matter what. However, if this was a padlock, all of those would be different combinations with the same 4 things because PBRG and BPRG would be 2 totally different lock combinations, right? So when order matters, I have more options. When order doesn't matter, I have fewer options. So in this situation, I'm going to be using a permutation because I'm going to have 17 factorial divided by 17 minus 4 factorial because order does matter. So in this situation, my answer is going to be that 57,120 we got when we did this before we divided by that R. Does that all make sense? All right, we have time for one more problem, and then I'm going to turn it back over to Dr. A. If 4x minus 6 times 5x plus 3 equals ax squared plus bx minus 18, what is the value of 3a plus 1/2 b? This is a fun one. So really, they're just trying to throw us off here. I just need to figure out what is A and what is B, and I just need to use basic pre-algebra to plug them in to 3A plus 1/2 times B. That's all I'm doing. I'm just using some basic pre-algebra to throw it back into that original formula, right? So with those two, and I know that my iPad disconnected again, with those two different factors, I'm going to use my FOIL method, my distribution method. So I'm going to do 4x minus 6 times 5x plus 3. I'm going to distribute my 4 all the way through. So 4x times 5x is 20x squared. 4x times 3 is plus 12x. Negative 6 times 5 is negative 30x. Negative 6 plus 3 is negative 18. Hey, look, those match. So 20x squared minus 18x, because 12 minus 30 is 18, minus 18. Now, I know that A is 20, and I know that B is negative 18, so I can literally just plug it in. 3 times 20 plus 1/2 times negative 18. 3 times 20 is 60. 1/2 times 18 is 9. 60 minus 9 is 51. When you see a problem like this, don't freak out because it looks different than what you're used to. You have the skill set. You have the ability to solve it. So don't freak out when it's something a little bit different. Take a step back and use the skills that you have to go ahead and solve it. All right. I hope that you had a great time tonight. I am going to turn it over to Dr. A. If you have any questions at all, please don't hesitate to ask me in the comment box. I will be checking the comment box throughout the week to see what questions that we have. I am not able to see your comments tonight. So if you made a comment or you asked me a question and I wasn't able to answer it, that's why. So I will absolutely answer your questions next week. Please let me know in the comment box what questions you have. What do you want me to go over next week? And I look forward to seeing you next week. Have a great week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.